The safe lock label on a ground fault circuit interrupter receptacle indicates that the GFCI has tamper-resistant features that prevent children from inserting objects into the receptacle. The label meets 2003 Underwriters Laboratories requirements, refers to the Underwriters Laboratories Standard 943 for 2003. This standard established stricter requirements for ground fault circuit interrupters, including increased sensitivity to ground faults. An article in Electrical Contractor magazine discusses ground fault circuit interrupters that fail closed. The 2003 Underwriters Laboratories standard addressed the issue of ground fault circuit interrupters failing closed by requiring increased sensitivity to ground faults. However, it is important to note that no ground fault circuit interrupter is foolproof, and there is still a potential for them to fail in certain circumstances. Firstly, damage to the ground fault circuit interrupter or its wiring can cause failure. Secondly, overloading the circuit can lead to a ground fault circuit interrupter malfunction. Thirdly, grounding issues can also cause problems. Finally, surge protectors or other devices connected to the ground fault circuit interrupter can interfere with its operation. It is recommended to test ground fault circuit interrupters regularly and replace them if they fail the test. Testing is vital for ensuring the device will function correctly. Ground fault circuit interrupters are designed to protect individuals from electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person touching a live wire. The ground fault circuit interrupter quickly interrupts the circuit when it detects a ground fault, preventing a potentially fatal electrical shock. The 2003 Underwriters Laboratories 943 standard aimed to improve the reliability and performance of ground fault circuit interrupters. The increased sensitivity requirement means that ground fault circuit interrupters manufactured after 2003 are more likely to detect and respond to ground faults. Despite these improvements, ground fault circuit interrupters can still fail for various reasons. Damage to the device or its wiring can compromise its ability to detect ground faults. Overloading the circuit can also cause the ground fault circuit interrupter to malfunction. Grounding issues, such as improper grounding or loose connections, can interfere with the ground fault circuit interrupter's operation. Surge protectors or other devices connected to the ground fault circuit interrupter can also affect its performance. Regular testing is essential to ensure that ground fault circuit interrupters are functioning correctly. The test button on the ground fault circuit interrupter simulates a ground fault and verifies that the device trips as expected. If the ground fault circuit interrupter fails the test, it should be replaced immediately. When selecting a ground fault circuit interrupter, it is important to choose a device that meets the latest Underwriters Laboratories standards and is appropriate for the intended application. Ground fault circuit interrupters are commonly used in bathrooms, kitchens, and other areas where water is present. They are also required in outdoor locations and on construction sites. Different types of ground fault circuit interrupters are available for different applications. Some ground fault circuit interrupters are designed for use with specific types of appliances or equipment. It is important to follow the manufacturer's instructions when installing and using a ground fault circuit interrupter. Proper installation and maintenance are essential to ensure that the device functions correctly and provides adequate protection. Ground fault circuit interrupters are an important safety device that can help prevent electrical shocks. Regular testing and maintenance are essential to ensure that they are functioning properly. Understanding the limitations of ground fault circuit interrupters and taking appropriate precautions can further enhance electrical safety. For instance, surge protection can help protect against damage from power surges. It's also important to ensure that electrical circuits are not overloaded. Ground fault circuit interrupters are just one component of a comprehensive electrical safety plan. A ground fault circuit interrupter does not protect against overloads or short circuits. Circuit breakers or fuses are needed for that protection. Ground fault circuit interrupters should be installed by a qualified electrician. This ensures that the installation meets all applicable codes and standards. When a ground fault circuit interrupter trips, it is important to determine the cause of the trip before resetting the device. If the cause is not identified and corrected, the ground fault circuit interrupter may continue to trip. In some cases, a ground fault circuit interrupter may trip due to a nuisance trip. This can occur due to minor electrical disturbances. If nuisance tripping is a problem, a ground fault circuit interrupter with a higher trip threshold may be needed. Ground fault circuit interrupters are constantly evolving as technology improves. Newer ground fault circuit interrupters may offer additional features, such as self-testing and remote monitoring. Staying up to date on the latest ground fault circuit interrupter technology can help ensure that you have the best possible protection against electrical shock. The Safe Lock feature, while primarily intended to prevent children from inserting objects, also contributes to overall safety by preventing accidental contact with live parts within the receptacle. This feature is particularly beneficial in homes with young children, as it reduces the risk of electrical injury. The Underwriters Laboratories 943 standard is regularly updated to reflect advances in technology and to address emerging safety concerns. The 2003 revision represented a significant step forward in ground fault circuit interrupter performance. Subsequent revisions have continued to refine the standard and improve the safety of these devices. Ground fault circuit interrupters are not a substitute for safe electrical practices. It is still important to follow all applicable electrical codes and to take precautions when working with electricity. Always turn off the power before working on electrical circuits or equipment. Never touch electrical wires or components with wet hands. Use properly insulated tools and equipment. Ground fault circuit interrupters are a valuable tool for enhancing electrical safety, but they must be used in conjunction with other safety measures. Testing a ground fault circuit interrupter involves pressing the test button. This button simulates a ground fault. When the test button is pressed, the ground fault circuit interrupter should trip and interrupt the circuit. After the ground fault circuit interrupter trips, it can be reset by pressing the reset button. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. Some ground fault circuit interrupters have a self-testing feature. This feature automatically tests the ground fault circuit interrupter on a regular basis. If the ground fault circuit interrupter fails the self-test, it will indicate this with a visual or audible alarm. Self-testing ground fault circuit interrupters provide an added level of assurance that the device is functioning properly. Ground fault circuit interrupters are an essential safety device for any home or business. They protect against electrical shock. Regular testing and maintenance are essential to ensure that they are functioning properly. Ground fault circuit interrupters are designed to trip quickly in response to a ground fault. The tripping time is typically less than 0.25 seconds. This rapid tripping time minimizes the risk of electrical shock. Ground fault circuit interrupters are available in different amperage ratings. The amperage rating of the ground fault circuit interrupter should match the amperage rating of the circuit it is protecting. Using a ground fault circuit interrupter with an incorrect amperage rating can be dangerous. Ground fault circuit interrupters are also available in different voltage ratings. The voltage rating of the ground fault circuit interrupter should match the voltage of the circuit it is protecting. Using a ground fault circuit interrupter with an incorrect voltage rating can be dangerous. Ground fault circuit interrupters are typically installed in place of standard electrical receptacles. They can also be installed in circuit breaker panels. When installing a ground fault circuit interrupter, it is important to follow the manufacturer's instructions carefully. Incorrect installation can compromise the safety of the device. Ground fault circuit interrupters are an important part of a comprehensive electrical safety plan. They are designed to protect people from electrical shock. Regular testing and maintenance are essential to ensure that they are functioning properly. Understanding how ground fault circuit interrupters work and how to use them properly can help prevent electrical accidents. Electrical safety is everyone's responsibility. By taking simple precautions, you can help protect yourself and others from electrical hazards. Electrical codes and standards are constantly evolving to improve safety. Staying up to date on the latest codes and standards can help ensure that your electrical system is as safe as possible. Ground fault circuit interrupters are a valuable tool for enhancing electrical safety. They should be used in conjunction with other safety measures to provide the best possible protection against electrical shock. The information provided here is for general educational purposes only and should not be considered a substitute for professional electrical advice. If you have any questions about electrical safety, consult with a qualified electrician. An important point to remember is that ground fault circuit interrupters protect people from dangerous electrical shock hazards and are a key safety device.